Okay, starting with example 4, we're going to go the other direction. They're giving us a general rule, and they're telling us that this sequence they're giving us starts with a of 1, and usually we start with a of 0. But first thing you want to look at is how much are these changing by? Are they changing by a regular amount? Yeah, when we look at the first differences here, it's all plus 4. So that means there's 4 times n in our, so it's a sub 0 plus 4 times n because we're going up by 4. And if we look at a sub 1, and they tell us that a sub 1 is equal to 5. And so we can solve for a sub 0. Looks like it's equal to 1. So our general rule, a sub n equals 1 plus 4 times n. Let's go back and find a sub 0 on these. Same idea here, but there's not, the differences are not constant, at least not for the first differences. So I get a 9, 12 to 27, looks like that gives me a 15, and then 48 minus 27, that'll give a 21. Okay, that's not so good, but our second differences are actually a constant. Okay, so the difference between 9 and 15 and 15 and 21 is both 6. This just suggests we've got n squared somewhere in our pattern. In order to figure that out, let's take a look at specifically n equals 1, and for n equals 1, a sub n is equal to 3. All right, so using some kind of squaring, how could I get from squaring 1 to a 3? Well, I could try 1 squared times 3. Okay, let's look at the next one, 12. And n equals, a sub n equals, sorry, n, I got that backwards, n equals 2, and a sub n equals 12. If I look at 2 squared, and 2 squared times 3, that would be 4. That definitely gives me a 12. Let's look at the last one, n equals 4. And it's 21. Is that going to be 4 squared plus 3? Sorry, 4 is not 21, but 48. So 4 squared times 3, 4 squared is 16 times 3 is definitely 48. So a sub n, my general rule, is going to be 3 times n squared. I know there is a squaring in there somewhere. Sometimes there's a number being added. Sometimes there's a number being multiplied. Sometimes there's a number being added inside the squaring. So play around with the numbers as you're trying to figure out what the pattern is. I like example 6 because, hey, we just have 1/4 and it's changing from positive to negative to positive. So what that means is that we've got a -1 to the n power, or maybe n minus 1, and that's multiplying 1/4. So let's take a look at n equals 1, and we have a -1/4. If I go -1 to the 1 power times 1/4, well, that will definitely give me the -1/4. Look at n equals 2, that gives me a positive 1/4, and -1 squared times 1/4 will definitely give me a positive 1/4. So my rule is going to be, let's write it somewhere. It's close to this, a sub n equals 1/4 times -1 to the n. All right. Okay, now we're getting into what we call recursive formulas. And in the book, they go over the Fibonacci sequence, which is definitely a recursive formula. I'm just going to show it up here. You get 1 and 1 and 2, and by adding the previous 2 terms, we get the next term. Okay, so the 5 depends on the term before it and the term before that. You can look in the book to see how they script that out, but let's take a look at this. Now, with a recursive formula, they always have to tell us what to start with. And we're looking for the first 5 terms. So A1 is 3. Let's look at what happens for A2. That's going to be negative 3 times A to the 2 minus 1 minus 2. That's negative 3. A to the 1 minus 2. So in this formula, it's always using the previous term to multiply by negative 3. So my second term, I get negative 3. A sub 1, they told us was 3 right there. And minus 2. So I get negative 9 minus 2. That's a negative 11. A to the third, it's going to use the previous term. So it's going to be negative 3 multiplying A sub 2. Now you can plug in the n. You can plug in the n of 3 and subtract 1 of it from it, but hopefully you can tell that what we're doing is just multiplying the previous term times negative 3. And my previous term was 11. Let's start keeping track of this. So my 5 terms are starting with a sub 1 of 3, then negative 11. Okay, negative 3 times negative 11 is a positive 33. Positive 33 minus 2 is 31. And a sub 4 is going to be negative 3 times 31 minus 2. And that will give me a 3 times 31 is 93. Negative 93 minus 2 is negative 95. And now a 5 is going to be negative 3 times negative 95. And minus 2. 3 times 95 is 385 minus 3, sorry, 285 minus 2, which gives the last term of 283. So there's my first 5 terms of that recursive sequence. All right, that's enough for this video.